Welcome to 12.2 Translations and Rotations. So anytime you perform two or more transformations on a figure, you are performing a composition of transformations. So just to review a little bit, a transformation is when you change a figure. Now let's talk about translation. A translation is a transformation that is formed by the composition of two reflections in which the lines of a reflection are parallel lines. So a translation can be thought of as a sliding movement of the plane. So the very first example I ever showed you in 12.1 was actually a translation. And it looked like this. We had a triangle, and officially I'm reflecting it twice, about two different parallel lines. So there's the first reflection, which we studied in 12.1, but what happens if I reflect it again? The figure is going in the same direction as it started, but it's in a different location. So it looks like it actually slid horizontally. The same thing is true with any polygon at all. So let's go ahead and reflect it twice. So it looks like it actually slid. This time it's kind of a diagonal, but it did slide across the two reflective lines. Now a rotation is different because it is formed by the composition of two reflections, but the lines of reflection are intersecting lines. So again, we're still going to reflect twice, but we're going to almost pivot about that point of intersection. So the first line of reflection would give me this image, but it becomes my pre-image because I have to do it again. So if you look, it almost looks like a fan, a blade of a fan. It rotated like the point X was a pivot point. That's called the center of rotation instead of a pivot point. I just want you to think of it as a turn, even though you're technically reflecting it 2 times. This direction was clockwise. Now the magnitude of the rotation is twice the measure of the acute or right angle between the lines of reflection. So if we needed to know that angle, then that was how much it rotated. So for example, if the measure of hx and h double prime was 95 degrees, then the magnitude of the rotation is 95 degrees. The angle between the lines of reflection is only 47.5 degrees. So it's easy there, you just double it. Now, an identity transformation is a transformation that maps each point of a geometric figure onto itself. So if you were to rotate, say, enough times around, you would end up right where you started. That would be one type of identity transformation. Okay, so that's all it is for the notes today, but I do want to draw your attention to one thing in your book. There is a picture. This is crazy because this is a national curriculum that you go, but on page 506, the Ferris wheel at Cedar Point is on the page, which I think is hysterical, but it talks about it rotating 10 degrees between cars while loading passengers. So there's an overlapping red radii and silver kite shapes in the design. So I don't know, I just think that was kind of a point of interest in your textbook, because not every day that Ohio is in a national textbook. Okay, so back to your WSQ summary. I need you to consider the following three things here. You have three different problems to think about, and I want you to think about a three-dimensional transformation. So think of a figure like a cube or a prism, and you're going to think about how that image would be transformed. So here are the three things. First, how would it be transformed through a single plane, through parallel planes, or through intersecting planes? So those are the three kinds of transformations we've already talked about, but just in one plane. Now I want you to think about them in three dimensions, and the planes will act as lines. That's my hint to you. So email me your thoughts and go ahead and check your answers, and I'll see you in class.